Here we're going to talk about simplifying rational expressions and multiplying and dividing with those expressions too. First of all, a rational expression is going to be the ratio of two polynomial expressions. What I have here, 8/12, it's technically a rational expression, but it's really just a fraction. And thinking about what you would do with fractions is going to be real helpful in pointing the way on what to do when it comes to the more complicated rational expressions. So when we think about simplifying 8/12, what we do is look at the factors of 8 and the factors of 12. For instance, 8 is 4 times 2, and 12 is 4 times 3. And it's those common factors of 4 that we end up canceling, because 4 divided by 4 is 1. And once all the common factors are canceled between the numerator and the denominator, what we're left with is our simplified fraction, 2/3. So what about when the fraction turns into a legitimate rational expression, where I have a polynomial in the numerator and a polynomial in the denominator? Well, the idea is still the same. We want to factor the numerator and the denominator and see if they have any in common. Since both of these are quadratic, I can factor x squared minus 4x plus 3 into x minus 3 and x minus 1. When it comes to x squared minus 6x plus 5, that would be x minus 5 and x minus 1. And what we're going to do, of course, is cancel common factors. Since we're multiplying both numerator and denominator by that x minus 1, those are the factors that cancel. And what we're left with, that x minus 3 in the numerator and the x minus 5 in the denominator, that makes our simplified rational expression. So let's try a few more just to get some more practice. When we have something that looks like this, x squared times x squared minus 5x minus 14 over 4x times x squared plus 6x plus 8, it's not about distributing and multiplying this thing out, it's about factoring it. So when it comes to the numerator, we want to take a look at this quadratic and factor that into x and x, and then minus 7 plus 2. In the denominator, I'm going to leave that 4x right here, and factor x squared into x and x, and factor 8 into 2 times 4. So plus 2 and plus 4. Once everything is completely factored, now we can go through and look for common factors. Obviously we have the x plus 2. But we also have, in the numerator, there's this x squared that can cancel with the x that's in the denominator. That'd still leave us with 1x up in the numerator. Now that everything's canceled, we can see what we have left. In the numerator, it's x times x minus 7. And in the denominator, I still have that 4 and the x plus 4. Now that it's all simplified, and I know there's no other common factors that are going to cancel, we should multiply this one out into x squared minus 7x over 4x plus 4. This one looks a little bit more complicated, but just take each factor individually and see if you can factor it. So when we look at this 4a squared minus 3ab, each term in there has an a. So that's what I'm going to factor out, is the a. And I'll be left with 4a minus 3b. For that a plus b, there's nothing that we can do there, so I'm going to leave it as that a plus b. In the denominator, that 3b minus 4a, that looks innocent enough, and that there's no common factors between them. When it comes to 5a plus 5b, obviously there's a 5 in there that could factor out. When we go through canceling common factors, the a plus b's are going to cancel. But I do want to get back to the 4a minus 3b and the 3b minus 4a. They look almost exactly the same, except they're in the reverse order. And we do know that when it comes to subtraction, order does matter. So let's take a look closer at what's in the denominator. I'm going to leave this numerator the same, and I'll still have the 5 here. But what we can do with the 3b minus 4a is to factor out a negative 1. When I do that, 3b divided by negative 1 is negative 3b. And minus 4a divided by negative 1 is plus 4a, which means that one little factor that's down there, after we factor out a negative 1, is really 4a minus 3b. Then we can get our common factors to cancel. And this whole thing simplifies down to a over negative 5. The important thing to remember is that when you want to switch the order of subtraction, you have to factor out a negative 1. Well, how about multiplying? Think about how you would multiply two fractions together. For instance, when I have 6/21 times 14/15. What we would do first would be just to find some common factors. For instance, this 6, we would rewrite it as 2 times 3. 21, we'd look at that as 7 times 3. In the next fraction, 14 is 2 times 7, and 15 is 5 times 3. And when we look for factors to cancel, we're looking for the same factor in a numerator that is in a denominator. So this 7 is going to cancel. As far as the 2 goes, it doesn't cancel because the other 2 is also in the numerator. The 3 that's in the numerator will cancel with either one of the ones that are in the denominator. Now that there's nothing left to cancel, we just see what we have left. In the numerator, I still got a 2 and a 2. In the denominator, it's a 5 and a 3. So we multiply them together for 4/15. We want to take that same idea over to a rational expression like 6c over 5d times 15cd squared over 8d. And look for things to cancel. For instance, I know that 5 is one of the factors of 15. So 15 being 3 times 5, the 5 is going to cancel. Also, as far as numbers go, 6 and 8 share a common factor. 8 is 2 times 4, and 6 is 2 times 3. So it's the 2's that are going to cancel. Now when we move over to the letters, the variables are in there. The d in the denominator is going to cancel with one of the d's in the numerator. Then the second d would cancel with the other d that was in the numerator. After all the canceling is done, let's take a look at what we have. As far as numbers go, we have 3 times 3 is 9, and c times c, which is c squared. In the denominator, the only factor that's left is that 4. And this is our simplified rational expression. So how about one that's more complicated? We have x squared minus 6x minus 16 over x squared minus 16 plus 64 times x minus 8 over x squared plus 5x plus 6. Man, we have to factor it. Have to. And just take them one side at a time. For instance, that x squared minus 6x minus 16. We know we're going to have to factor it into x and x. Factors of 16, they're going to make a 6, 8, and 2. If I negative 8 plus 2, that'll make the negative 6. In that denominator, factor x squared into x and x. Factor 64 into 8 and 8, both of them being minus. Moving on to the next fraction, my numerator is x minus 8, and it's going to stay as x minus 8. In the denominator, factor x squared into x and x, and 3 times 2 makes 6, and plus 3 plus 2 makes that 5. So, look for factors to cancel. And just going through, I got that x minus 8 is going to cancel, and so is this other one. Then for x plus 2 over x plus 2, that cancels, and it looks like there's nothing left to cancel. Since I don't see any more factors in the numerator, what's left is a 1, and the only thing left in the denominator is x plus 3. When it comes to dividing rational expressions, think about what you would do if they were fractions. And what we remember is that dividing by a fraction is the same as multiplying by its reciprocal. So if I started off with 5/6 divided by 10/7, I would keep the first fraction the same and multiply by the reciprocal of the second one. So it's 7 over 10. And now do the same thing that we were just doing, looking for some common factors. 5 goes into 10 2 times. I can't cancel the 2 with the 6 because they're both on the same side of a fraction. So what I'm left with in the numerator is a 7, and in the denominator is that 6 times 2, or 12. That's the idea that we want to go with when the fractions turn into these rational expressions. If I'm dividing by a fraction, I want to multiply by the reciprocal. That means leaving the first fraction the same, 18x y to the third over 7x squared y squared. And instead of dividing by the fraction, we're going to multiply by its reciprocal. So what was in the denominator will now be in the numerator, and what was in the numerator will now be in the denominator. And start looking for some things to cancel. Right in the last fraction, I see right on top of each other, I got these x squareds and these y's. They're going to cancel. 7 goes into 35 5 times. 6 is going into both 18 and 12. It's 6 times 2 is 12. 6 times 3 is 18. Then I noticed that this x can cancel with one of these x's. And 2 of these y's can cancel with 2 of these y's. Let's see what we have left. In the numerator, I got 3, this y, and this 5. 3 times 5 is 15, and that y. In the denominator, there's this x and this 2. So 2x is the denominator, and here's our simplified fraction. So what about when it's a much bigger rational expression? We're going to do the same thing. We're dividing by a fraction, so we need to multiply by its reciprocal. We also know that we're going to have to look for common factors, so while I'm writing out this step, I'm going to factor each side of each fraction. X squared minus 16, that's going to be x plus 4 times x minus 4. And in the denominator, there's a common factor of 12, which will leave me with y plus 3. Instead of dividing by that fraction, I'm going to remember that we multiply by the reciprocal. So the y squared minus 3y minus 18 is what's going to come up in the numerator. Factoring that, y squared factors into y times y, and 18 factors into 6 times 3. Negative 6 plus 3. That makes that negative 3y that's in the middle. The x squared minus 12x plus 36 needs to come down in the denominator. And we're going to factor that. X squared factors into x and x. 36 factors into 6 and 6. Both of them negative. Now that it's turned into a multiplication problem, we look for those common factors. Y plus 3 and y plus 3. Those two cancel. And that's it. You may be tempted to say that these two are going to cancel because they both got the minus 6 in them. But one is y minus 6 and the other one is x minus 6. And so no, nothing's going to cancel. So now what do we have left over? In the numerator, I got that x plus 4 times x minus 4, which was x squared minus 16. And there's also this y minus 6. In the denominator, there's a 12. And x minus 6 times x minus 6 was x squared minus 12x plus 36. Do we need to multiply it out a little bit more? Not necessarily. I really wouldn't recommend multiplying that numerator out. Right now I do have it into these nice factors where one of them has x's in it, the other one's got y's in it. So why don't we just leave that separated? In the denominator, if you wanted to, you could distribute that 12 and have 12x squared minus 144x plus 432 if you wanted. Honestly, if you left it like this, I'd be more than happy. I want to finish this video up with two rational expressions that look like this. This is called a complex fraction, where we have fractions inside of fractions. And one of the more important things that you can do with this problem is to identify where is the main fraction bar. And that's going to be right here. I have one fraction in the numerator and one fraction in the denominator. That's important for us because as far as fractions go, a fraction means division. So I'm taking the numerator, a plus b over 4, and dividing it by a squared minus b squared over 4. And we just saw that when it comes to division, dividing by fraction is the same as multiplying by its reciprocal. So that first fraction stays the same, and when I change division to multiplication, the 4 that was in the denominator is now in the numerator, and that a squared minus b squared goes in the denominator, which we should factor into a plus b and a minus b. Now that everything's factored, we look for common factors between the numerator and the denominator. Obviously that 4 is there, but also so is a plus b, and those cancel as well. After all the canceling is done, I don't see anything left in the numerator, so the only factor that's left is 1. In the denominator, I have a minus b. Here's one last big, ugly, complex fraction. And the best thing that we can do to start this problem off is identify where is that big fraction bar, the one that divides this complex fraction into 2 halves, and it's right there. So let's rewrite it as division, as x minus 2 squared over 2 times x squared minus 5x plus 4 being divided by the denominator, x squared minus 4 over 4x plus 10. Dividing by a fraction is the same as multiplying by the reciprocal. So when I write this as multiplication, that x minus 2 squared, I'm also going to factor it into x minus 2 times x minus 2. Divided by 2. And x squared minus 5x plus 4, I'm going to factor into x, and minus 4 minus 1. The division is now turning into multiplying by the reciprocal. So that 4x plus 10 that was in the bottom is now going to come up to the top. And I'm going to factor out the common factor of 2. And I'll be left with 2x plus 5. In the denominator, the x squared minus 4 that used to be in the numerator is now down here in the denominator. We factor that into x plus 2 and x minus 2. Now that everything is completely factored, we look for common factors between the numerator and denominator. That 2 is one of them. So is the x minus 2. After that, I don't really see any. So, what are we left with? In the numerator, I see an x minus 2 and 2x plus 5. In the denominator, I got x minus 4 times x minus 1 times x plus 2. And whether you should multiply this out or not, that's kind of up to you. As they get bigger, I notice I got 3 factors in the denominator. You do know how to do this, and it's okay if you do. I would definitely want to see this. All right. Definitely show that fraction before moving on to trying to simplify it. If you do, you would multiply the numerator out into 2x squared, and I have plus 5 and minus 4x, which leaves me with plus 1x minus 10. In the denominator, we got x squared minus 5x plus 5, and that still has to be multiplied by x plus 2. If you really want to check your skills and see if you got it, for multiplying out that denominator, you should end up with x cubed plus 2 and minus 5 makes minus 3x squared. And I got a 5x minus 10x is minus 5x and plus 10. So you could check my work on that, but I believe that's right.